Okay, I'm back talking about this MCR suitcase. It's wanted to cover a couple things on the back side, as well as figured I'd fix the red 12 volt unregulated wire that was disconnected from the filter cap. But a couple of things that I missed on the previous or wasn't really clear that I was explaining was, this is your game transformer that puts out unregulated AC power. That unregulated AC power actually comes in as these green wires here from the front side to these rectifier diodes. After it gets fused, it goes into these rectifier diodes, and that's what converts it from AC power to DC power. So then the black is DC power unregulated to the filter caps, and then that goes out to your connector here. And then the red wires are coming in to the rectifier diodes here, which is the 12 volt unregulated, so it's about 18 volts positive on this side, negative on this side, and then that goes out as well. Another thing that these filter caps have is this drain resistor. So when the machine is powered off, obviously these are big caps and they would store a lot of power, but this drain resistor will actually drain the power from the capacitor as the game is powered off. And I was going to show a quick how-to on this meter as well, where you can actually see that capacitance dropping. The other thing that I wanted to talk about was, a lot of times people replace these big caps, and they're about, I think this one, the blue one for the 12 volts is a 50,000 microfarad capacitor, and the silver one over here for the 5 volts is 100,000 microfarad. So, and they're about $15 to $20 a piece, so not super cheap if you think about a $30 power supply and people wanting to put in just a switcher for about 30 bucks. So, but I figured what we would do is measure the AC voltage across them, which is one way you can determine whether there's a lot of noise on the line, whether the capacitors are doing their job. So we'll measure that as well. So hopefully my soldering iron is hot enough here, and we will solder on this wire. There we go, got it finally. Okay, it's on there good now. Alright, so what we'll do is we'll go ahead and power this on. There we go. So it's on now, and we're going to first measure our AC voltage coming in. So what we can do is actually put on our ground. We're on AC, and we'll measure AC up here. We have around 9.5 volts AC before the rectifier diode. And then if we come underneath, we'll see that the AC is dropping there. So let's change it to DC. And we have the 10.3 volts, which is your 5 volt unregulated on that capacitor. And we'll do the same thing for, actually it doesn't matter if we keep it here or here, but we'll do that on the 12 volt as well. So we got 16 volts AC, and then we'll come down on this side Okay. Change it to DC. And about 18 volts DC. So it doesn't matter because the COM is on both of voltages are tied together, so it doesn't matter there. Okay, so one of the neat features about this Brymen 235 is it has this auto volt setting, and what that will do is actually also put a little bit of load on it. So it's also a great way to drain the capacitor, but because if you didn't have a resistor, a drain resistor like this, you could actually use this meter to drain the capacitor itself of power. It might take a while, but what we'll do is it will actually power it off. Let me see if I can hold these here. Okay, so that's 10.4 volts. And let me turn that light on so it makes it a little bit easier. There we go. Hopefully you guys can see that. Like that. And then we'll go ahead and remove power. And then you can just see the voltage start to drain off of that capacitor. This is also a good way to kind of, with this meter, to kind of check if the capacitor has voltage before you actually put an ESR meter on it. That might damage the ESR meter if it didn't have a drain resistor of itself built in. And now it's safe to put that, an ESR meter on that, or even pull the capacitor out. So that's one thing. So let's go ahead and power back up. And now let's measure on the DC power side. To see if there's what the DC power is here. So we're going to go positive to there. So that's our 10.4 volts. And we could have measured this from the top side as well, from this connector as well on the top side. And I might actually do that. But what we want to do is we want to actually see, this is DC power, we want to measure AC voltage on it. So we'll do millivolts, AC millivolts, and we can see that there's no AC voltage on this capacitor. It's reading zeros. So that tells me that most likely this capacitor, this filter capacitor, is doing its job, is what my expectation would be there. Let me go ahead and turn that on, that light on. And we can do the same thing on this side. Negative here, positive here, 0 millivolts. So instead of replacing these capacitors at this point, I would think that they would probably be fine, that they are not the source of the hum that's being created on our 12 volt line in the system. So we'll put it on auto voltage again, drain the capacitor, and I'll unplug it real quick. Waiting for the voltage to go down, and then I don't even know if this ESR meter can measure that high. It probably only goes to like 10,000 microfarads, but we'll try it and see what it does. I haven't even tried it myself off camera, so we will check this out. Hopefully you guys can see that okay. Usually take the leads together. Zero them out. There we go. So let's see what this does. Hopefully I don't blow anything up. It gives a reading 0.019. Obviously it gives a reference. This particular meter gives a reference for a 25 volt cap. These caps are around 16 volts or 25 volts, I think, from the factory. And I also have a cheat sheet that you guys can't see behind me, but it only goes up to 10,000 microfarads, and it says 0.03 or 0.0, around the 0.01 for 10,000 microfarads. So I'm sure this is pretty low ESR as far as ESR goes. So I'm sure this cap is okay. So let's measure this other one. Now this is the 5 volt, which isn't even part of the audio circuit at all, but it's also reading relatively low there. Yeah, this meter's not the greatest, but you know, 0.016. If it was reading in the 0.1 or 0.2, 0.5 or higher, then I'd probably be concerned, but I don't have enough experience to say whether this is 100% good or not. But the fact that there's no you know, AC, let me see the right term for that. Yeah, they call that ripple voltage. So when you're measuring AC voltage across a DC line, you should have very little AC ripple voltage. So, and that's what a lot of people say cause the hum. So I think we're safe to say that the capacitors themselves are good. And there's a lot of debate on, you know, replacing big blue capacitors or just arbitrarily replacing these capacitors. But for 30 bucks, seems that you might want to measure them first if you can. That 30 bucks right there will buy you a meter like this, and a few more will buy you a meter like that. So definitely recommend that. I think that's all I kind of wanted to show, except for that we could have easily, based off of our little cheat sheet, we could have easily just measured that AC ripple voltage instead of from underneath at the filter capacitors. We could have just went in from, you know, pin 9 or pin 3 to pin 4 or pin 8 with AC power. So if we want to, I can show you that real quick. I know this is getting long, just for a quick synopsis video. But we'll make sure that our meter is on millivolts. It actually does temperature on this setting right here. It'll do, let's see if you can see that. It'll do temperature, millivolts on DC and AC power. And we're going to put, we just need one common, so we can come right through the top here. Let's see if I can fit it in here. Now that's the 5 volt line, so pin 4 and pin 9. And if we go to pin 6, that's the 12 volt unregulated. And again, we're measuring for ripple voltage, so we're kind of measuring if there's a lot of noise on the line. But the filter capacitors seem to be doing their job as far as this chassis is concerned. So hopefully that, guys, will help you some. And see if there was anything else that I wanted to cover. No, I think that's it. So anyway, that was just that's it on the power chassis, and I'm going to put everything back in the cabinet and actually see if our hum was caused by that disconnected ground or common or, you know, connection that we fixed there, and then I'll come back and actually show testing some resistors on this power board here as well. I've already done it, and this 4700 capacitor over here actually tests very, fine, and these two are actually testing bad. But again, there's a lot of people that just replace these capacitors, which you can do, but if they test okay, it's kind of just like shotgunning it. So anyway, we'll come back and we'll probably do a quick video on some of the power supply board as well.